Hello and welcome to CB Astronomy. Before I get started, I just have to make two quick things. So firstly is my friends and neighbours are doing some construction work, so if there is background noise in the video, I do apologise for that. There isn't much I can do about it, but yeah, I'll try to edit it out as best I can, but if I can't get all of it and you hear some hammering or sawing, I do apologise. And second thing is, so I'm a couple of weeks into the channel at this stage, and I just want to say thank you to everyone who's watched the videos and given them likes and subscribed to the channel. It really does mean a lot to me, and it's just spurring me on to keep on going. So thank you so much to everyone again. So yeah, today I'm going to talk to you about two naturally occurring phenomena that is really important to astrophotography and learning about the universe. So the two of them are the Doppler Effect and gravitational lensing. So so Doppler Effect. The Doppler Effect was made popular in general society by the Big Bang Theory Sheldon Cooper. One of the Halloween episodes, he dressed up as the Doppler Effect, and that's how it got heard of by most of society. But for those who don't know, the Doppler effect is the apparent change in the frequency of a wave caused by relative motion between the source and the observer. So what this means is that if an object and an observer are stationary, the waves will be emitted uniformly and there won't be any change in the apparent frequency. But the much more common occurrence is that the two will be moving relative to each other. So a common example of this is if an ambulance or guard car or anything with a siren really happens to pass by you. So as it approaches you, the waves will become compressed, and it will result in you thinking that the pitch is higher than it actually is. And then once it's past you and it's driving away from you, the waves become stretched out, and this will make you think that there's a drop in the frequency. But this is an Earth-based example and a very specific one. The most interesting one is the ones that happen in space. So the Sloan Digital Sky Survey, it's a telescope up in the mountains. Its sole function is to map out the position and the luminosity of distant galaxies. Now when a galaxy is moving towards us relatively, the light waves emitted from the galaxy become compressed together and will shift from the visible region up to the ultraviolet region. And conversely, when the galaxy is moving away from us, the light waves emitted from it will become stretched out and will result in the waves shifting from the visible region down to the infrared region, which we can't detect with the naked eye. But with special cameras on the SDSS, it's able to pick these galaxies up and maps it out for us. So that's the Doppler effect. The other thing I wanted to talk about was gravitational lensing. So gravitational lensing wasn't really known about too much when our first telescopes went up. But the universe is made up of different types of matter. The moon, the sun, the planets are all made up of what we call regular matter or baryonic matter. This makes up about 4% of the energy mass percentage of the galaxy, of the universe. Sorry, I was thinking very small scale there. But quick history lesson. So in the 1930s, a astronomer named Fritz Zwicky was observing the Coma cluster. This is a massive cluster of galaxies all bound together gravitationally, and long story short, he measured the velocities and the mass of all the galaxies and concluded that they were moving a lot faster than they should have been, because at the speeds that they were moving, they should have been able to free themselves from the gravitational lock that they're in. So he concluded that the galaxies were a lot heavier than he originally accounted for. So he said, right, most of the mass of the galaxies must be invisible to me. And fair play to him for copying it on. But we'll fast forward to the 1970s, and astronomers started seeing stars on the outer rims of their host galaxies orbiting at really high speeds, and they were saying, why isn't that star floating into intergalactic space? Because the mass of the galaxy has, and the velocity it's moving at, it's like its velocity is just too high, it should be shooting off, but it's not. So they concluded again that the mass of the galaxy must be much higher than just the regular matter that they were measuring, and they concluded that the culprit was dark matter. The most interesting thing about dark matter is that it's not made of the same stuff as regular matter. So if it doesn't emit or absorb light, it can phase through regular matter undisturbed. It doesn't have any electrostatic interactions, but it does interact gravitationally. So So say you're given the job to take a photo of a distant galaxy, but there's a pesky clump of dark matter obscuring your view. What'll happen? So as the light travels from the galaxy to you, it'll encounter the dark matter, and this will bend the light around the dark matter, and then by the time it reaches your telescope, you'll have one distorted image of a distant galaxy. But now that we know about it, we can compensate for it. We can actually use it to our advantage. The main application of it is to use massive galaxies in the foreground of an image to act as like a natural telescope, and this gives us the ability to photograph galaxies that would have been previously obscured to us. So if you can picture, so you have a massive galaxy here, another one here, you can use the front one as a magnifying lens essentially, and then get a clearer image of the galaxy behind it. Yeah, so that's all I have for you on two of them. So that's two naturally occurring phenomena that obscures astrophotography. I hope you enjoyed the video. I apologise, I've had 3 cups of coffee and I'm a bit jittery. So yeah, usual stuff will be in the description. The Instagram, Twitter and the Snapchat is there now as well. Please like and follow them. If you enjoyed the video, like that as well. The subscribe button for the channel will be in the top left corner of the video. If you haven't already, please click that, it would really mean a lot to me. Yeah, if you have any questions about what I've covered, post in the comments and we can have a chat about it. Yeah, thanks for watching, take it easy.